Crystal such an impressive structure, such an impressive building, given that it was designed back, I think, in 2009, 2010, the design process started,
Yeah.
which is very impressive, all the systems it has. And my first question would be, given that it was designed almost 10 years ago, how flexible is the design of the building to allow to update the technology, to allow adding new systems that might be more up to our current knowledge and research right now? And have you made any updates since the opening day?
So it is. Well, first of all, thank you for your questions, everyone. And so it is a very sort of flexible build. It's flexible in some regards. So some of the technology inside can be updated and improved and changed. And so since then, we're on our third BMS system or BMS software, so building management system. And so like different lighting systems were introduced to have more energy efficiency. Let's say we've so there's ground floor, first floor, and the second floor. So the first floor has been sort of altered to have like dividing walls that can be used for conferences and meetings. And so basically these are like flexible walls. And then when you, let's say if you're putting together 2 or 3 or 4 or 5 of these rooms for a larger one, the room controls can be adapted for the full room rather than having it in separate parts. So in that sense, it's quite flexible. But overall, we consider this to be like a living lab. So it's not permanently fixed, and so it can sort of like taken, be used in better sort of, just it has more flexibility with its technologies.
That's great. And so you are making updates on the building itself in terms of adjusting to the needs of the functions. Also, as you said, being a living lab, I guess you're also updating the technology and adding new systems or testing new systems to see how it works. I was wondering, you said about the room control. Is that something that's available to the occupant of the room, or the room control is just available only to operation managers? Mm-hmm.
Yeah, so both. I mean, it's being tracked externally and in the building, but also, you can control various settings when you're inside the room too. Yeah.
The students are also wondering if the overall performance of the building has met the expectations of the predictions during the design phase.
Yeah, absolutely. It has met the predictions, and there's also been identified areas for improvement, specifically regarding energy efficiency. So as we go forward every year, we get we improve in our devices and sort of there's always improvements in sort of different technologies you can use within a building. But generally, it's met the predictions.
I also saw in your presentation that in both the LEED and BREEAM scales, the index for materials was not very high in terms of what the building was able to do. Could you elaborate a little bit more about why that is happening?
So it's low because like 50% of the points in the material section are given to sort of reusing existing structures that are on the land. And before this was built, there was nothing on here on the site in the past. So I guess that was one of the reasons for a lower score.
Another question would be, how dynamic are the current smart buildings in terms of how do they respond to what's happening in the building? Is it automatic? Does it need a human interaction? How can AI help in automating these responses of the building to the occupants and the situation happening?
Right. So I mean, like human interaction is still needed, but like we sort of in this building, we haven't yet implemented any AI or technologies that for sort of making it smarter outside of the human context. but I guess it's the next step. So that's definitely what they're thinking of, ways to improve and how it can self-adapt. Um, and so in that regard, there is a program that's being developed called the Optimum Start Stop program. And that basically measures the time for a room like to get to a certain temperature, um, sort of depending on the outside temperature. Let's say in the morning at 9 a.m. or 8 a.m. you want it to be 21 degrees, or sorry, that's 21 degrees Celsius, which is like 75 Fahrenheit. So let's say, when you wake up, you want it to be like that. So it would have to sort of monitor ahead of time when it would need to turn on um, the heating. So that's called the Optimum Start Stop program. And then there's also one thing that will probably be implemented in this building as well as a predictive heating controller. So it is linked to a weather forecast, so it can know ahead of time if there's, let's say, going to be a heat wave in the city. It doesn't need to have sort of the same heating or the same like measures that were taken in the previous days. So it's linked to future projections, and it's basically considers the storage capacity of the thermal mass in the building.
You said that you're now starting to introduce some AI technologies. In your presentations, I saw on the slides that you have video surveillance system.
Mm-hmm.
From my understanding, it's there for safety reasons, such as to detect some, maybe an intruder, or in general, detect some abnormal behaviors. I'm wondering if this detection is happening automatically, or if, again, there is a need of the human to watch the video in order to be able to see these behaviors.
So you have both. So firstly, there's a system called Site IQ, and it's a Siemens product which identifies moving objects in any location. For instance, it can detect like even leaves on the floor to cars or larger objects like people, and so you can correlate. It can detect any of these movements in certain zones, and they're called policy zones. And so these then, if let's say some vital area of the building and there's some kind of movement happening, it can notify the human on site or the security on site. So it's sort of a surveillance, but a bit smarter. So it's not like one person or a group of people just looking at cameras the whole time. It's more like it can detect what movement is happening and then notify you.
How could you use, for example, these cameras or any kind of sensors that record, for example, activity of movement, and maybe we can use this understanding of people activities to further improve the comfort inside the building? What is the temperature? What is the air quality based on the activity they're doing? For example, if they're exercising, maybe they need more air, maybe they need lower temperature, or something along these lines. If they're sleeping, something else. I was wondering if you think this is in the plans of what you were hoping to see one day in the future, not necessarily in Crystal, but in general, in a smart building?
Yeah. So, I mean, this building was mainly used for offices and working, and then also event space. But I guess it's interesting if you think about like for a gym or a hotel where people are sleeping or exercising. I mean, I guess it doesn't really track people themselves at the moment. It just it can track or detect movement, and so you can sort of, using indoor positioning, you can track individuals in a room, and then it can sort of identify what you're doing. And in the future, I mean, there are some startups that I guess, I mean, I know that like we work with a sort of have it can detect if your mobile phone is using GPS. It can detect if you're in a certain area of the room, and it would keep the lighting on there and not somewhere else because it knows there's no one in that area. So I guess it, save on lighting in that way and heating and so on. But yeah, I think we haven't gotten to that stage yet where it can know exactly what you're doing, if it's sleeping or exercising. And then, yeah, but that's a very, very, very valid point, because I think there's a statistic, it's like 90% of our time, or in most like developed countries, 90% of our time is spent indoors. So yeah, indoor air quality is probably just as important as how we think of outdoor air quality.
Of course, when you're talking about tracking people and understanding their activities, you are collecting data, recording them or not, you're still collecting some data. So a lot of students are interested in understanding what are the challenges in terms of data privacy and security, in terms of the social aspect, maybe. So I was wondering, what is your opinion on that?
Yeah. So, I mean, the software, there's two sides. It can either be used like for good, well, it can be used sort of to improve like living conditions or working conditions of people in any area of a building. But then it can also be used like to analyze video of people in a crowd. Let's say, can detect pickpocketing or facial recognition of people who are sort of on a wanted list, or things like that, maybe in like airports, train stations, larger crowded areas. In terms of being inside a building, I guess, yeah, like it's more about the movement rather than tracking of individuals. But yeah, it definitely is a valid concern about data privacy. But I think in the end, I mean, people, I think people sort of, we give up our privacy generally on a daily basis in exchange for convenience and speed and time of getting a service or product. Like, think about how much, you know, when you're moving around any city, if you're using Google Maps or Waze or so on. So yeah, I think as a whole, we do give away sort of data, but it's for the benefit of the larger community.
So since we're talking about data and data privacy, so you have currently collected about 6 years of data, more or less. I'm wondering, how are you utilizing these large data stores? Does it affect the design of the technologies? Do you use it for other buildings, improve Linux products? What uses are you doing of this data, and what lessons are you learning out of this data?
So it's being used generally to improve any of the Siemens products already in the building. And as I said, it's a living lab, this building, you could say. So there's constantly being field tests. There's constantly field tests being done. And then this data and results are used to improve our solutions in general when we come to a new customer or a city. So, you know, using past data, you can see sort of what's a better approach for a certain objective that a new customer has with their building. And for instance, like, this building was built in 2012, but I'm not sure when. So there's a new headquarters in Munich. I'm not sure exactly when that was built, but it was built afterwards, and that's 90% lower greenhouse gas emissions than most office buildings. So that could be achieved through, you know, past data that has been accumulated from this building and other ones that we monitor.
It's very hard to start deploying all these kind of technology systems and monitoring in all buildings, especially when we're talking about existing buildings. So some students were wondering how we can generalize the collected data and all these lessons learned from these few examples that exist, like Crystal or your Munich headquarters, and use those to implement specific systems, specific ways to monitor the building in existing buildings, in buildings that exist right now.
Right. So I guess the more you know about a building, the more you can implement into another one. And so, yeah, I could say, like, for existing structures, like, we monitor our own buildings and then also our customer buildings. And so, yeah, it's used, it's recorded, it's seen what has been, what's working, what's not. Then for the next building, you can see how to improve on that. Yeah, so I guess it's just a matter of when you have all these technologies and you've invested all that, how you can get the most value out of them and provide the best use for all this data we're measuring.
Do you think that all this data has an impact on the design processes? For example, when you're building a new building that you want it to be a smart building, do you think that is actually affecting the design process itself? Right. On how you start thinking about the building, about the design of the building because of the lessons learned?
So, I mean, building information modeling has more impact on building design and not so much from sort of experience from other buildings. So, I guess before you even construct a building, you would want to create what's called a digital twin or a virtual twin, and this helps to simulate building operations and identify where building parts can clash with one another. So like you can conduct energy simulations and different scenarios of tenants as it's still like only a virtual model, so it'll be cheaper rather than doing that after it's built.
In general, we don't see that many smart buildings out there, and a lot of the students are interested to know why current incentives are not aligned with having a sustainable future. Is the price of the systems, is a not understanding of the benefits you can get? What is in your opinion the reason why we're not having more smart buildings out there?
Well, in the end, it depends on who's funding the building and the construction and what are their interests, what are their goals. So some people, some companies build and just to sell, but then you have ones who build to operate and work in and live in. So it's about, I guess, aligning from the start and what's the goal, what kind of an impact you want to have down the line. So yeah, I mean, in generally in terms of incentives, I guess it costs more upfront, but it would pay off down the line. So like, I think like 20% of the cost is in the capex, and then 80% of the building cost is in the operating, so OPEX. And yeah, I think it depends on the what's it called, the sustainability targets and the corporate, the CSR of each company. Yeah, what do they want to achieve with this building? Is it just a quick short-term thinking, or a bit long-term and a bit more sustainable and better, like a larger impact thinking?
I'm wondering, at least in the UK, if the government has any specific incentives, or is there any legislation pushing the developers to make more sustainable buildings or reach some targets?
To be honest, I'm not that familiar with specifically in the UK. A lot of our work is covering around the world, but I mean, what I do know is that in the UK there's a big housing shortage, and so there is a sort of need and like strong need for building a lot of new buildings, and so in that process you could lose a lot of long-term thinking, as I mentioned, and sustainability objectives when you're building that fast. But then you start to think of new, like I'm sure you maybe have discussed already, or one topic is modular buildings, and how that can save a lot of time and money. Yeah, so modular buildings, I guess it saves a lot of time and costs when you're building, and it doesn't depend on the, let's say, weather. Sometimes you could have very bad weather conditions which don't allow for building on site. So if you could produce and manufacture all the parts of a building off-site and then deliver it or transport it to the site, that saves a lot of time. And then I guess in terms of sustainability, that also saves a lot of material and waste throughout the construction process. So you know exactly what you need, rather than building on site and then having a bunch of things at the end, which you probably didn't even think that. I mean, you would expect there's an excess, but then you don't know what you do with it. While when you're in a modular factory, you could reuse it for the next building. But so I guess that's when you're dealing with a housing shortage, you have to think of new ways of building rather than older, more conventional methods.
I don't know if you're familiar with the process of generating or creating innovative green buildings or solutions. And some students are wondering who is the decision maker in this process, and what is their responsibility, if any, to build sustainable and healthy future cities?
It depends on who's funding the product and the solutions in this building and the level of sustainability they want to achieve. But sort of usually the one who builds isn't the one who operates the building. You could have a developer who just wants to build it quickly and sell it, and then the people who are working in there, or students who are in the building, are not very happy with what was built. So I guess you have to sort of have a balance between sort of speed and sustainability.
Talking about smart buildings and smart cities, I want to come to the last question. Smart cities, smart buildings, smart people.
It's I think it is interesting because I think using smartphones and devices and technologies in our day-to-day lives can sort of influence our behavior, and like obviously first of all it will make us more aware of what's being tracked and so on, so it can make us smarter in our decisions and in our lifestyles. But then in terms of smart buildings, I think it's not just about the technology, it's also just like about the vision and the long-term thinking of what a building even is. So I think what's essential is to make the building future-proof, meaning to prepare it as much as possible for a change of usage. So for instance, to put in all the necessary technical infrastructure that we need for now, but maybe when, for instance, some air ducts or water pipes are in places where they might not be needed in the future. So what kind of a building can you design that can be modified depending on who's using it? So it could be like, maybe Siemens rents out a space or rents a building for 6 years or 4 years or 5 years, and then they move out elsewhere for various reasons, and then someone else moves in, like Facebook or Google or who knows what, and then they have different, maybe similar usage, but different needs. So how you can make that building adapt from the start to different occupants. So I guess that is the goal of what a real smart building could be. And then smart city, I mean it's all, why is it even called smart rather than just a city? So it all comes down to how each thing in the city is a better form of what it used to be. So is a train station just a train station, or is it filled with sensors and monitoring devices and that produces data based on people's movement and steps in a certain area, which can then be maybe use that motion of people to create energy. And there's a startup here in the UK, in London, called PaveGen, which generates energy from people's footsteps on pavement. So yeah, in the end, all of this data comes together, and then I think the key point is for it to be open. So without open data, I think there'll be a lot of opportunities missed, because let's say company X owns this section of the land, and then the Department of Transportation owns that part. But if they're not sort of keeping their data open and shared, then you can miss a lot of potential new solutions for what a smart city could actually be. So yeah, a lot of collaboration is needed. Um, yeah, I think that's overall covering some of the smart points, smart thinking.
And to thank you so much for doing this and for agreeing to join us through recording for a second time to make sure we we have a good flow in our class. So again, thank you so much.
Yeah, you're very welcome. And if there's any further questions, feel free to email me. Yeah, I hope everyone does very well in this class and in your overall degree, whether it's master's or PhD. And hope to sort of work with you in the smart city or smart building domain in the future.